Question 34. We have monochromatic electromagnetic radiation incident on a metal surface, and three observations about the electrons emitted from the surface are, okay, so this is the photoelectric effect, and the question is which observations are inconsistent with the wave model. So we have the wave model vs the photon model, right? And so let's look at what intensity is, because all of these seem to be asking about intensity. So intensity is essentially the power per unit area, right? That's the definition. And we know power is energy for time per unit area. And what is frequency? Frequency is 1 over time period, or per unit time, right? And so if frequency increases, we have intensity increasing. So, right, because this then becomes bigger. Then we also have, so that's 1, we have 2. When the area, sorry, the area is constant. When the energy increases, we have increased intensity. And so let's see if this helps us. Maximum energy of electrons does not depend on radiation intensity. And so the wave model tells us, yes, it does, right? The maximum energy of electrons does depend on radiation intensity. And so this is inconsistent. And so this option would be correct. This is inconsistent with the wave model. The photon model tells us that energy is simply hf, right? Related to the frequency. This is a work function. So here intensity just means we have more photons, not more powerful photons, but just more photons in a unit area, right? So higher intensity means more photons in a unit area, or per second. So we know that I is correct, and we can move on to number 2. The number of electrons emitted in unit time increases with radiation intensity. Now, that is true, right? The number of electrons emitted per second increases with intensity, and we saw that here. The wave model says that is true. True according to wave model. So as frequency increases, intensity increases. And therefore, this is consistent with the wave model and is wrong. Actually, it's the opposite, right? So intensity increases, then we have frequency increase. So it works both ways, and this one's asking about intensity increasing. And so no electrons are emitted when the frequency of radiation is less than a threshold value. And that comes to this work function part, right? When the frequency is below the threshold frequency in the photon model, no electron is ejected, right? No electron ejected because there's not enough energy. Not enough energy. And so the wave model says the opposite. If the electrons have enough intensity, there's enough light, enough photons hitting that area, then the electrons will eventually soak up enough energy to then escape, regardless of frequency. So this one is inconsistent with the wave model. And so that one is also true. And so the answer should be B.